Okay, we're still in the 6.1 because they got so many factors we need to know. Okay, the first one is a series, the position of the electrochemical series. Okay, number 2 is yesterday we learned about the concentrations. Okay, now it's the third one. Third one is the electrode. Okay, electrode means the center, this one, the silver color, this one cathode and anode, we call it as an electrode. Okay, different material of the electrode also will be different about the electrolysis result. Okay, normally the electrolyte result, they will focus to the anode. Okay, we want to focus to the anode, just like the concentration. They also got changes for the anode. Cathode, actually, they don't have any changes. Okay, they're almost the same one. Okay, now we're going to see the following. Okay, factor that will affecting the products of the electrolysis. Okay, 3 factor is it. The first one we finish, second one finish. Okay, today we need to go is a type of the electrode. Okay, what type we go to use? Actually, we got some electrode we can choose lah. Normally it's a carbon. Okay, then another one, sometimes we're using the copper. Okay, and sometimes we're using the silver. Okay, depend the situations. Okay, so from here, type of the electrode. Okay, now we're going to see some of the example, different electrode, what's the effect. Okay, type of the electrode that will affect the selection of the ion to be discharged. Okay, remember normally discharge we follow the electrode chemi series. Okay, which one is the lowest one? They will discharge first, is it? Okay, but when the electrode is a different, they also will be affected. So electrode is a different, so that means we no need to follow the chart lah. Okay, now you see which one situation we need to follow the electrode. Okay, first one, if the metal we use, metal means the electrode, if the electrode method we use at the anode is same as the metal ion in the electrolyte. Okay, I go to show the diagram first. I go back to show about the diagram. Okay, this one is the cathode, anode is the electrode, is it? So that means metal in the anode, if they are same like the ion, same like the electrolyte. So example, if the anode are using copper, then the electrolyte are using copper 2 sulfate, means 2 also got copper. This one we call same as. Okay, if different means if the anode are using carbon, okay, but the solution are using copper, that one we call difference. Okay, so now the situation is if the metal in the electrode, okay, the same like the ion in the electrolyte. We see what happened when they just same. Okay, then we go through this part. Okay, if the metal U as the anode is same as the metal ion in the electrolyte. Okay, now we see at the anode what happened? The metal atom will be ionized. Okay, metal inside the metal. Okay, example, that one is a copper. So that means the copper will be ionized. Okay, to form the positive ions. And also this one ion, they will dissolve into the electrolyte. So that means the metal, when they just ionize, they become smaller already. They become lighter because some of the copper already ionized. So they become positive ion, go where? Go into the electrolyte. Okay, dissolve into the electrolyte. So that means some of the copper will dissolve into the copper 2 sulfate. If the same lah. Okay, so what happened for the cathode? Okay, cathode actually don't have any changes. So the metal ions will be discharged. Okay, for the cathode, the metal ion for the electrode, they will discharge. Then after that to form the atom of the metal. So which are deposited at the cathode. So that means it's the same now for the cathode. The ion in the cathode, they will discharge. Okay, discharge, we follow the electrochemical series. Which one is the lowest, then they will discharge. Okay, after discharge to form the atom of the metal, then this one metal, they will deposited at the cathode. So that means the cathode will become bigger and bigger because the metal already discharged. After that, they stick to the electrode. So the electrode later, they will become thicker and thicker because they're deposited at the cathode. Okay, that means they stick to the cathode. So finally, the mass of the cathode will be increasing. Okay, cathode will be increasing, then the anode will be decreases because they dissolve into the electrolyte. Okay, so the concentration, what happened? Electrolyte, the liquid concentration, what happened? So the concentration of the metal ion in the electrolyte does not change. Okay, does not change. Why? Okay, you see some of the atom already deposited at the cathode, but the concentration also never changed. Why? Because the anode also got dissolved into the electrolyte. Okay, if you say anode also discharge, cathode also discharge, then this one concentration will be different. Okay, because both also discharge, so that means the concentration for the electrolyte, the ion no more already, because you both also go to discharge. But for this one situation, only the cathode discharge. The anode don't have any discharge. The anode just give the ion into the electrolyte. So they say dissolve into the electrolyte. So finally, concentration metal ion in the electrolyte does not change. Okay, because the rate of metal atom ionized to form the metal ions at the anode same as the rate of the metal ions discharge to form the metal atom deposited at the cathode. So that means the process at the anode and process at the cathode is the same. One release, one absorb. Finally, the concentration constant. Okay, this one is when the situation is the same as electrode material, same as the material of the electrolyte. Okay, only anode got changes. Anode, they will ionize, then positive ion produced, dissolve into the electrolyte. Okay, cathode still the same. They choose which one is the most electropositive. After that, they will discharge. Okay, after discharge, they produce an atom. Then this one atom you stick to the cathode. So the cathode will become thicker and thicker lah. Okay, so that means concentration become constant. One release, one absorb, finally they become constant. Okay, so this one is the first situation when they are same as the material. Okay, now we go to second one. Second one is a different material. So if the type of the substance they use at the anode not same as the type of the metal ion into the electrolyte. So that means different. Maybe they're using carbon, then the solution, what you're using? You're using copper, different thing. So different thing, we're going to see what happened for the anode. That means the atom do not dissolve. Just now dissolve, is it? So this one atom no dissolve. They're just like the normal. Normal means what? Discharge. Okay? So from here, the negative ion in the electrolyte are discharged at the anode. That means the same the process at the cathode. Cathode always discharge, is it? But the anode now they also discharge because the material is different. So they don't have any changes become ion, dissolve into the electrolyte. No. Okay, they just do the normal process. Okay, for the cathode, still the same. Ion are the less electropositive, they will discharge. Okay, then after that they dissipated for the cathode, so they become thicker. Okay, for this one situation, concentration will be dropped. Why? Because both also discharge, anode also discharge, cathode you also discharge. Finally, what happened for the electrolyte? Electrolyte become drop, the concentration become drop. Because both you also take already. One absorb, another thing also absorb. They never release. So finally, the concentration of the metal ion electrolyte. Electrolyte means the liquid. Okay, inside got liquid. They want the solution we call electrolyte. Then it decreases. Okay, the concentration decreases because the positive ion in the electrolyte are discharged to become metal atom deposit at the cathode. Okay, so you absorb, then the anode never provide, they also absorb. So finally, got concentration that will dropping. Okay, so this one is the differences. If they're using the electrode, they're not same like the electrolyte. Okay, I understood. Electrode is the iron part when they join with the cathode and anode, positive and negative. Electrolyte is the solution into the beaker, the one we call electrolyte. Okay, so now we're going to see some example for these situations. Okay, example 1 is electrolysis for the silver nitrate solutions. Okay, we see silver nitrate understood like in front sure is a positive, nitrate is a behind sure is a negative ion. So from here, the electrode using what? Silver. So you can see both is the same. Solution, silver nitrate. Then the electrode also silver. So this one situation is both is the same. Okay, when both is the same, what happens for the anode? Anode will dissolve into the solution. Cathode is no changes, still discharge. Okay, so we go to see one by one. Okay, first one, the ion will be present for this one. Electrolysis is what? Silver ions. Okay, silver ion, the first one. After that, you got nitrate ions. Okay, after that, you sure got hydrogen and also hydroxide. So we need to find out which one is a positive, which one is a negative. Normally, the first one, silver, is a positive. Okay, nitrate should be the negative. Then hydrogen is a positive part. Then hydroxide should be the negative part. Okay, hydrogen, normally, after the electrolysis, they will produce hydrogen gas. Okay, hydroxide, after electrolysis, they will produce oxygen gas. Okay, so now we're going to see what happened for the anode. Okay, cathode, no changes. We see what happened for cathode first. Cathode, actually, no changes. Okay, these two is a positive. Okay, this one is an example. You see, the solution we're using Ag. Ag is argentum. Argentum is a silver. Okay, now you can see the electrode. Okay, now the electrode I also using silver. That means both also silver. Okay, no need to see about cathode, only anode. Both also silver. That means later you can find the ion will be dissolved into the solutions. Okay, so we're going to see the explanation first. Okay, for the cathode actually is no changes. We see, go and explain for the cathode. Cathode is a negative electrode, so they will attract all the positive ions. Okay, which one is a positive? Silver and also hydrogen. Okay, they will attract to the cathode. Okay, after that you continue. The silver ion will be discharged. Okay, silver and hydrogen. Okay, we follow the chart. Hydrogen, below we got copper. Okay, after copper we got silver. After silver we got the gold atom, gold. The day you ask me, atom is what? There's a gold. So that means silver is below the hydrogen. So that discharge, we need to choose the silver. We never choose hydrogen because hydrogen is at the top. So from here, silver ion will be discharged because the silver ion is less electropositive than to the hydrogen. Okay, finally, what happened? The silver will deposited at the cathode. So that means finally the silver will go where? Go to the spoon. Spoon is a cathode. So finally your spoon become more silver, more thicker of the silver. Okay, the silver come from where? Come from the solutions. Because solution already is a silver. Okay, so the cathode still the same. Okay, you must remember what will attract to the cathode. Then you must mention which one will be discharged. Okay, either silver, either hydrogen. After the last one, you must say what will deposited at the cathode. This one is a 3-step you go to explain about the cathode. Okay, how about the anode? Okay, we see the anode. Anode must be attracted the negative ions. Okay, so we go to first part for the anode part. So for the anode part, positive electron. Okay, they will attract negative ion. So silver ion and also the silver atom at the anode, they will ionize. So that means at the silver part, the anode now is a silver. You can see the diagram. The anode now is a silver. The silver ion from this one cathode, this one electrode, they will produce the silver atom at the anode ionized. So this part, the silver, they will ionize. After ionize, they go where? Go to the solutions. So from here, number 2, the nitrate ions, because they attract the nitrate ions and also hydroxide, is it? So the nitrate ions and the hydroxide are not discharged. So for this one anode, we no need to find discharge. I don't care you nitrate or you hydroxide, no need to discharge because now it's the same electrode. Electrode material and solution is the same, so they don't have any discharge at the anode. What will happen? They will dissolve. Okay, number 3, the silver electrode. Okay, the silver electrode, they will dissolve in the electrolyte. Okay, so that means for this one situation, we don't have any discharge for the anode. They only dissolve the atom. The atom depends for what atom you use lah. If copper, then the copper will be dissolved. If they're using silver, so the silver will be dissolved into the electrolyte. Okay, so when it just dissolve into the electrolyte, so that means this one silver, there will be less mass. The mass will be reduced. Okay, become lighter because some of the atom already ionized. Okay, ionized, after that they put inside the solutions. Okay, so from here, the last one we need to mention about concentration. Finally, the concentration for the solution, what happened? They're still the same because anode dissolve. Then the cathode, they will absorb. Okay, dissipated at the cathode. So finally, one absorb, one release, finally become constant. So from here, we mention concentration. Concentration of the silver ion in the electrolyte does not change. Okay, why? Because the rate of silver atom ionized to form silver ions at the anode, okay, is same as the rate of the silver ion discharge. Okay, first one is ionized. Second one for the cathode is discharge to form silver atom at the cathode. So both is the same. The rate transfer is the same. Rate transfer means what? Kadar pertukaran. Okay, kadar melaku tindak balas. So the time for the discharge and also ionized is the same. So finally, the concentration, no changes. Okay, this one is the first, the example when both electrolyte and also electrode, the material, we can see the chemistry material, chemical material is the same. Okay, solution using silver, electrode also using silver. So finally, the anode will dissolve. The silver atom, they will dissolve into the electrolyte. Okay, then the cathode still the same. Okay, finally, you need to mention about the concentration does not change. Then reason why does not change. Then you're talking about the rate lah. Okay, so this one is first example. So now I want to go another example. It's a different one. Okay, different one. Okay, now I'm using carbon electron. Carbon electron memang different lah. You see this one is a silver, this one is a carbon. So different thing. So different thing, you see what happened? Okay, the ions present still the same. Silver, nitrate, hydrogen, hydroxide, still the same. So the positive is a silver and also the hydrogen. Okay, both is a positive. Okay, now we go to explain the cathode first. Cathode actually don't have any changes lah. So you see cathode is what? They attract the positive ion. Positive ion is a silver and also the hydrogen. Okay, they will attract. So finally, the silver will be choose to discharge lah. Okay, because there's a lower part. There's a less electropositive than the hydrogen. So finally, the silver will deposited at the cathode. Okay, still the same. Okay, now we see anode is what happened. Okay, anode. Anode don't have any dissolve. That means the process same like the cathode. Exactly the same, but they attract the negative ion. So from here, they will attract negative ion. Now the negative ion is what? Nitrate, nitrate, and also the hydroxide. Okay, they will attract. Finally, we go to choose lah, which one you want to discharge. So the less electron, that one positive is it. So this one is a less electron negative one. They will choose to be discharged. So from here, we got hydroxide. Then we got nitrate. So we choose hydroxide because the hydroxide is the bottom one. So from here, hydroxide ion will be discharged because the hydroxide ion is less electropositive than to the nitrate. Nitrate is number 2. Hydroxide is the bottom one. Okay, so finally what they produce? They produce the oxygen gas, okay, at the anode. Okay, so this one is a differences for the same material and different material. Okay, some students will ask, cathode, why not hydrogen to produce? Because silver already choose to discharge. We never choose hydrogen. Okay, we never choose the hydrogen because hydrogen above, silver is bottom. So for cathode, actually, we don't have any gas to produce. They only produce the silver. And the silver, they stick to the cathode. Okay, finally, you can see both sides also don't have anything dissolved in the solution. No. Okay, because the material is a difference. So how about the concentrations? Okay, concentration means now the concentration for the electrolyte of the silver ion in the electrolyte decreases. Okay, now your solutions, your concentration will be decreases because the silver ion from the electrolyte already discharged to become the silver. Then the silver go where? The silver will stick to the cathode. Cathode already absorb the silver, then they stick to the spoon. Example, just now I put the spoon, is it? All the silver, they will attract to the spoon. Okay, so then the anode also never dissolve anything. Okay, they only discharge. So finally, you find it, the concentration for the liquid already decreases. Okay, already absorbed to the cathode. Okay, so finally, this situation, that means cathode and anode, the process is the same. Just the concentration decreases for the solutions. Okay, understand for this one or not? When the two electrode and also the solution is a different thing, totally different things. Okay, so this one is a factor for the electrode that will affect the solutions. Okay, finally the result for the electrolysis. Okay, this one is another experiment you need to copy. Okay, this one is an experiment related for the electrode, exactly the same. Okay, aim to study the effect of the type of the electrode on the selection ion to be discharged, okay, at the electrode. So from here, the problem statement, we need to find out how does the type of the electrode that will affect the selection of the ion to be discharged at the anode. We only find at the anode. Okay, hypothesis. You see, got two hypotheses. If the carbon electrode are used during the electrolysis, copper 2 sulfate solution. That means the electrolyte, they're using copper 2. But the electrode, you're using carbon. Then they ask you what happened. Okay, for the anode. What happened for the anode? Okay, after that, we see the number 2. Number 2, both also copper. Copper electrode. Then the solution is a copper 2 sulfate. Then they ask you what will be formed at the anode. Okay, so this one is a 2 hypothesis. They test by using 2 electrode. Okay, manipulate variable, what we control? We control the electrode. First, we're using carbon. Second one, we're using copper. Okay, responding. Responding means we cannot do anything one. Responding is a product. The products at the anode. Okay, what they will produce, we don't know. So this one become responding. Okay, which one become constant variable? Type and also concentration of the electrolyte. Electrolyte don't change. If you're using the copper 2 sulfate, then you need to constant. Okay, if you're using the silver solution, then you need to constant. Don't change about the electrolyte. Okay, so concentration of the electrolyte don't change. You're using 0.1 mole cubic decimeter, then you constant. Don't later you're using the high concentration, later you're using low concentration. This one, they will affect the result. Okay, so the first one, you need to copy aim until variable. Okay, second one, material. we're using 0.1 mole copper 2 sulfate solutions. Okay, apparatus like this. Okay, you can see the cathode part. Cathode part, they never put any test tube. Why? No gas to come out. Put test tube for what? So no need. Okay, only the anode they put the test tube because they can produce the oxygen. Depend the situations lah. So from here they're using copper 2 sulfate, then electrode carbon. Okay, starting they're using carbon electrode. So from here we see the procedure lah. You prepare the set like this. After that they're using copper 2 sulfate. Okay, fill completely the test tube. Test tube, you fill in the copper 2 sulfate. After that, you go to inverted. Okay, then we continue. Turn on the switch for 15 minutes. Observe and record the changes occur at the anode. We just see the anode. So test any gases released using the glowing wooden sprinter. So that means they want to test for oxygen or not. Okay, when they're just using the glowing wooden sprinter. Okay, observe and also recorded the result of the gas test. After that, you need to repeat. Now repeat, we're using the carbon electrode replaced by copper electrode. Okay, we see what happened. So from here, I don't want you using this one observation because this one too simple already. Okay, we want to write cathode and anode what happened. This one only is overall. Okay, so I want for the carbon, you need to explain about cathode and anode. For the copper, you also need to explain cathode and anode, what happened. Okay, so we don't want using this one observation, we're using this one. Okay, the observation. Carbon, they're separated by anode and cathode. We see what happened. Carbon is a different type. Okay, we're using copper 2 sulfate, is it? We're using this one. Copper 2 sulfate. So that means if I'm using carbon, means this one situation, the electrode is a different. Okay, what happened for the anode? Anode and cathode actually is the same lah, because this one, the situation, they don't have any dissolve, is it? So anode, they will find the less electronegative, they go to discharge. So what you can see for the anode, the gas release, they light up the glowing wooden sprinter. So that means the hydroxide will discharge. Okay, when they just discharge, they will glow in the wooden sprinter. Actually, is what gas? Oxygen gas produced. Okay, so from here, cathode, what happened? Cathode, same lah. That means the copper they will dissipate at the cathode. So the cathode become thicker. So from here, the cathode thicker, there's a what? Brown solid are deposited. Brown solid is a copper. So from here, this one brown solid actually is what? Okay, the copper is produced. Depend the solution. If silver is produced lah. They're using copper 2 sulfate, then the copper is produced lah. Okay, now if I'm using copper, both also copper. Solution copper, then the electrode also copper. So what happened for the anode? Now the anode, they start to dissolve. Okay, dissolve means they don't have any gas. Okay, copper electrode will dissolve and it become thinner. Okay, don't have any discharge. Only they produce the iron. After that, they will dissolve into the liquid. Okay, this one means what? This one means copper 2 ion are produced. Okay, copper 2 ion is produced. For the cathode, cathode no changes. Cathode still the same. Brown solid are deposited. Then the last one, copper is produced. So this one is the differences. Okay, differences for the electrode and also electrolyte. Okay, if they are same, so that means the anode, they only produce the ions. What ion? Depend the solutions. Depend the solution and also electrode what they use. If they're using silver ion will produce. Okay, if there's a different, that means only oxygen can produce. Okay, I don't care lah, but it's just different lah. Okay, using silver, copper, carbon also can, but it's just different, sure oxygen produce. Okay, so this one is a observation. So you need to write this one observations. Okay, after observation, you need to answer the question. Okay, this one question is from your textbook. Name the ion present in the electrolyte during the electrolysis. Okay, here is a copper 2 sulfate. So you need to mention the four ions will be create in this one electrolyte. Sure, the first one is a copper 2. Copper 2 ion is a positive that we produce. Number 2 is a sulfate ion that we produce. Okay, then you continue hydrogen and also hydroxide. Okay, these four will be produced for this one electrolysis. So copper 2 ion, positive 1. Hydrogen ion, positive 1. Sulfate ion, negative. Hydroxide ion, negative. Okay, when the question just asks you for this one situation, you must refer the diagram, what solution they use. Okay, number 2. Name the ion selected to be discharged or the ion produced at the anode for the following type of the electrode. Okay, for the carbon is discharged. Okay, so they ask you for the anode only. Don't care about cathode. Only anode. So from here, for the carbon anode, what happened? Anode only produce oxygen. Oxygen, is it? So from here, oxygen is a hydroxide ions. Okay, the question asks about ions. They never ask about gas. So we just mentioned hydroxide ions. Okay, for the copper electrode, if I'm using copper means same already. Solution and the electrode is the same. So what happened? What is the ions that we produce at the anode? So they will produce the copper ions. Copper 2 ions. Okay, so they don't have any gas. They follow the solution. Solution using copper 2, then they produce a copper 2. Okay, so they only got 2 questions from your textbook. Okay, conclusion. Hypothesis is accepted lah. So the first one you need to write like this. Okay, B, you see so long, is it? Actually, they copy from the hypothesis. Okay, you can refer back to the hypothesis. We just copy from there only. Okay, if carbon electrode are used during electrolysis of the copper 2 sulfate solution, hydroxide ion will discharge at the anode. So hydroxide will discharge at the anode. If are using copper electrode are used during the electrolysis, copper 2 sulfate solutions, what will produce? Copper 2 ion are produced at the anode. So they just copy from the hypothesis. So you go to add one more word, the hypothesis is accepted. Then you copy all the things from the hypothesis. So this one is a final conclusions. Okay, so your report must from the aim until last one, conclusion. Still the same inside your experiment books. Okay, so this one is your first homework. Okay, then we need to discuss about the exercise. Okay, yesterday exercise. So the first one I'm going to show. Okay, state the 2 types of the electrochemical. So this one is the one starting we already learned 2 types of the chemical. First one is the electrolytic. Remember electrolytic from the electric produce chemical. Okay, another one is the terbalik, chemical cell. Chemical cell is terbalik. From the chemical produce electric. Okay, so from here B you need to fill in the blank with the following choice answer to show the process of the energy changes. So first round, electrolytic cell is from the electrical go to the chemical. Okay, chemical means terbalik. From the chemical produce electrical. Okay, I think this one no problem for yours. Okay, then we go to number 2. You need to tick. Okay, tick the electrolysis process. What should be included? Okay, we must have the electrode. Okay, we must have the electrolyte because solution. Then we must join with the battery. A beaker, not we using beaker, also can using the beaker, pail, another thing also can. Important they can put the electrolyte in, not exactly the beaker. So from here, the important component, electrode, electrolyte, and also battery. Okay, this one is the main component we need to use. Okay, then we go to the Find out which one type of the electrolyte allow the flow of electric current. This one we know solid cannot flow. Only the aqueous and also the molten that can let the current, let the electron to move lah. So that means got current. Okay, we need to label. Okay, first one, you see the circuit. This one sure is a battery lah. Okay, so the battery positive is the longer one. The positive join sure this one is a anode. The shortest one, this one is a negative. Negative, they join with the cathode. Okay, and this one solution, we call it as a electrolyte. Okay, battery, and the last one is an electrolyte. Okay, fine, they call you to show the arrow, how to flow of electron. They never say current, they say electron. Electron is the terbalik one. Okay, current, how to flow? Current from the positive, they start to flow. Then go back to negative. But the electron is the terbalik. So electron terbalik means they start from the electron, come down and go back to the positive. So you must see very clear. If they ask about flow current, then you draw positive, go down. If they show about electron, so you need to show terbalik. Electrons start to flow, negative start to flow, then go back from the positive. Okay, this one is how to flow of the electron. Okay, then this one they call you to classify the following ions into positive ion. Which one is a positive ion? Then you can refer the table lah. Which one is a positive? Okay, so from here you see the positive ion hydroxide is a negative. Okay, negative. So you're going to see some of the answer here. Hydrogen is positive. Aluminium, lead, zinc, copper, magnesium. So O is the metal one. Normally that one is a positive. Okay, negative one, sure we got hydroxide, sulfate, and also nitrate. Okay, you can depend for the table. Table we got cation and also the anion is this. So you can see the differences. Okay, remember, for you to memorize one, the one is pop what? I also forget the zombie one. Okay, I'm going to find out. That one is pop start can make any zombie in the town lost his control. That one is a positive one. Okay, for the negative one is a flower so nice can buy in orchard. That one is a negative one. Okay, you can find from there. Okay, so from here we need to go to the next part. Okay, next one is arrangement. Just now I told you arrangement, is it? So this one, electropositive decreases. Okay, after magnesium is what? Okay, after magnesium is what? Magnesium is a make. Pop star can make any zombie. Any is what? Any is
aluminium.
Aluminium. Okay, after that, I want electronegative decreases from the up go down. Flower so nice can buy in orchard. So that means you can mention about so sulfate is here, is it? Okay, you can mention about the nice, you can mention about the can, you can mention about the buy and also in. Orchard is the last one. So from here you can mention about the nitrate, chlorine, bromine, and also iodine. Either one, because they got big gap at the center. Okay, flower in front. Then this one is a so. Okay, this one is a nice can buy in orchard. Orchard is a hydroxide. Okay, so from here you can mention about the four of the negative. Okay, so from here you can see the ions that will be discharged. Okay, at the anode and cathode for the each following electrolysis. So from here you see magnesium nitrate solution. Magnesium sure is a positive one, no? Nitrate is a negative one, no? So anode is a positive. Anode must find the negative ions. So from here for the anode, they will produce hydroxide. Okay, hydroxide. Okay, cathode, they will produce hydrogen. Okay, they ask about what? They ask about the ion that will discharge. Ion discharge. They never ask about which one ion you attract. They ask discharge. So discharge, magnesium and also hydroxide. Magnesium produce hydrogen. Nitrate produce hydroxide. So which one will be discharged? Magnesium at the top. So they sure will choose about the hydrogen. Okay, nitrate and hydroxide sure is a hydroxide because nitrate at the top, is it? Okay, flower can flower is what? Okay, Jella is what? Flower? Nice.
So nice.
Nice, so nice. Okay, so that means nitrate at the top. So sodium and sulfate. Sodium is positive. Sulfate is negative. So sodium produce also hydrogen. Sulfate also produce hydroxide. So from anode, they sure will choose sulfate or hydroxide. Sulfate or hydroxide?
Hydroxide.
Hydroxide at the bottom one. Normally we choose the hydroxide lah. Okay, for the sodium and also hydrogen. So we need to choose sodium
Hydrogen.
Hydrogen.
So we choose hydrogen. Okay, last one. Copper sulfate. So copper is a positive one. Positive together with the hydrogen. So sulfate together with the hydroxide. So first one, you tell me sulfate or hydroxide we need to choose. For the anode. Sulfate or hydroxide. We still hydroxide. Okay, for the cathode, you want to choose copper or hydrogen?
Copper.
Copper is lower than hydrogen. So from here we choose copper. Okay, for the discharge. Okay, then we go number B. State the gas that we produce at the anode and cathode for the every electrolysis. Okay, concentration hydrochloric acid 1.0. 1.0 means high, high concentration. For the anode, what happened? Okay, so for the anode, you can find chlorine gas. Okay, they don't have any choose which one is the lowest, then they go to discharge. When they just concentration high, we choose chlorine already. No need to choose about the hydrogen or hydroxide. No need to choose hydroxide already. Okay, so from here, what they produce? Hydrogen gas for the cathode. Cathode is a hydrogen gas. Suppose if their concentration is low, they produce oxygen one. Okay, this one produce oxygen, this one produce hydrogen. Okay, but now the concentration is higher. So they follow lah. If they're using chlorine, then chlorine gas will produce. Okay, so from here, if the concentration is very low, so very low, they go back to the normal lah. So what happened from an anode? Oxygen produced lah. And the cathode, hydrogen produced. So this one is a normal. Okay, so this one is a factor concentration. Okay, then we match. Okay, match the correct hydrogen gas and oxygen gas. Okay, hydrogen gas, we're using what to test? We're using the burning wooden sprinter. Burning one, that means got fire one. When you just put in, you produce the sound, it's a pop sound. Okay, oxygen, we're using the glowing wooden sprinter. That means they don't have any fire, they're just of red color at the wooden. So when you just put in the oxygen, then the red color, they want the glowing wooden, they will give the fire to produce. Okay, they become lighter. So that one is testing for oxygen. Okay, then this one we need to choose for the litmus paper. Okay, gas change moist red litmus paper into blue. So you tell me what gas? Halogen or alkaline? Blue color.
Alkaline.
Blue color is alkaline. Okay, now the color moist blue chain become bleach. Blue chain become bleach. You tell me alkaline or halogen? So it's halogen. Okay, halogen they produce is a white color, no color one. Okay, glowing the wooden sprinter ignite. Okay, in the presence of, okay, they make it become glow. So there's an oxygen. And the last one, pop sound. When you see pop sound, sure is hydrogen. Okay, so this one is all the answer for the yesterday exercise. Hope you finish all the things. Okay, so I give you the answer already. Actually, you can keep it lah. You don't need to pass to me because you can get the answer. Okay, so this one is what lesson? I need to present for today. What you need to do, experiment. Please copy the full experiment 6.4 in your experiment books. Okay? So the last thing you need to do, attendance Google Form today. Okay, Google Form, help me to type here. What is the code? Okay, the code is, I also forget what's the code. Okay, the code is anode. ANODE, capital letter. Then after that, hashtag 1234. Okay, 1234 is a number. So help to type here. So everyone, thank you for your attendance.